Hi, everybody. Thank you for joining us. We're going to go ahead and get started. So we're excited to introduce today's topic, how to deploy and run smart contracts on EOSIO, the radically performant blockchain platform for building distributed and scalable applications. Your instructor today is Phil Mesnier. Phil is a lead contributor to the EOSIO platform. And with that, I turn it over to you, Phil.
All right, good morning, everybody, or afternoon or evening, wherever you are. As Nikki said, I'm Phil Mesnier, and I think most of you know who I am, but if you don't, I'm the blockchain practice lead here at OCI, and I've been a member of the core development team at working with Block One on the creation of the EOS platform. So today we're going to talk about smart contracts and building them and deploying them. And we're also going to highlight a new tool called EOS Studio that the brilliant people at Obsidian Labs has produced. And you can actually download the browser, or actually use the web-based version directly by going to eosstudio.io/web to get started with that. So today I've had an agenda showing on the screen. Right now we're going to go through a brief demonstration of use of a smart contract. I'm going to go through the big reveal, which is the new EOS Studio here, so now I don't talk away from the microphone. Yeah, talk about the EOS Studio a little bit. Then we're going to focus on the code behind my demo. Then we'll talk about transactions a little bit, about account management, product permissions, and closing questions. So this is really just a sample or a survey of what it takes to build a smart contract. There's plenty more. There's plenty more involved that we'll be able to get into at another time. So the demo for today, I have a simple tic-tac-toe game, and I'm going to hope that this connects okay. So I have a couple of accounts already set up for it. Okay, so this is a really simple contract, and it's what I'm showing here is the client side, and you can see it's pretty simple. You identify a couple of players, you open the game, and click on the X and the O, and it's pretty standard, straightforward stuff. What's really interesting, however, is not the playing of tic-tac-toe itself, but the fact that all the state, all the information used to render the game is stored on the blockchain, and it's stored in a smart contract. So now let's bring up the EOS Studio IDE. Now, I'm going to log out so I can show you from start. So when you download or when you log in, see where this mic is. All right, I'm going to try to get a little closer to the mic better. Anyway, so
Makes it better.
there you go. All right. Yeah. So this is the EOS Studio IDE, and I'm using this because I found it really convenient for creating a smart contract and doing all the tedious work that normally you have to do with command line tools like Cleos, which today we don't have to worry about. So the first thing you have to do, well, as you can see, they have a lot of helpful information on the screen when you go to the web version. So first thing you do is you have to log in, and so you do that by clicking on the little person in the upper right corner. Log in, and the very first time you do this, you have to associate with an account, and I'm going to use my GitHub account, which I've already configured. So it kind of jumps through that, and there's my little face. Next thing you want to do is select the network that you're going to connect to, and so you slide one over to the left, and you can do the cloud, which is what I've got selected here, and the alternatives are mainnet, which I would not recommend you use until you are actually ready to deploy for real, because the mainnet, of course, has real resource implications and real money involved, and so not that. But once you get beyond the cloud use, or if you're using the standalone version, the local host, you want to test using test nets. There's Jungle, which has been around since the inception of, since nearly the inception of EOS. And there's Killin, which I believe is in China. I've never worked with them. Or you can define a custom network, which we're not going to bother with. Anyway, so once you got your network set, you need to define some accounts. And the accounts are necessary because when you have a smart contract, you have to allocate resources for that contract to do anything. You have RAM, of course, and CPU and net, and those require an account so that you can, excuse me, so that you can actually stake tokens and associate with that account. We'll get back to accounts later on. Next is contracts, and contracts are basically code that's been assigned to an account, and so the contract name is an account name. But excuse me one second. I apologize. Doing these, talking a lot makes my throat dry. Anyway, so using a contract, of course, that's code applied to an account. And of course, we'll explore this in greater detail. The fourth tab up here is the project tab. And this is the thing that's most interesting for us right now. And you can see I've already got a few projects that I've been fooling around with prior to this webinar. So we'll pick the one that's related to our tic-tac-toe project and load that up. And as you can see here on the far left is a file viewer, file explorer, and there's an editor window. Okay, so this is actually, before I jump to that, I'll show way over here. So if you do create new project, you have to give the project a name, and the project name doesn't have to necessarily correlate to the name that you bind it to. So we'll just call this sample 2 because I created a sample 1 earlier. When you create a project, you see a couple of things. First is it starts as default access privilege is private. And you also see over here that it's created some source for you. So when you create a sample, when you create a new project, you automatically get a little hello world application. So it kind of deprives you of the joy of typing in a hello world as your first application. But it also makes it very easy for you to see what that does. So I come up here to the little hammer, which is the build tool, and build the contract. And then I can wait for it to finish. Okay, perfect. And so then I can do a deploy. And that's the little whale guy. We're going to deploy to my select account or my sample account. Okay, so it's already got the hello world on there, so that's why it didn't load again. But that's okay. Anyway, so so let me move back to the one that's a little more interesting. So here I've created a separate source and include file for the game. And so, right. Okay, so now let's dig into the source code view a little bit and see how and see some of the details associated with creating smart contracts. So smart contracts for EOSIO deployments are written in C++, and they use some advanced C++ adornments, such as attributes on the contract, on the class, and on some of the elements of the class. So these attributes are actually used by the smart contract compiler, which is the generation tool. And here we want to identify this class, OCI tic-tac-toe, as being the class for the EOSIO contract, also called OCI tic-tac-toe. All contract code you want to derive from the contract base class. And it gives you some features that you can use, in your for accessing data and privileges and whatnot. So the next element to see here is we have a struct for the game, and this is adorned with the alias or with the attribute of an OCI table. OCI table, or EOSIO table, is the primary data store for is the primary data store for smart contract data. And so when you create an action, the action will have to retrieve the data from the data store, and it does it using whichever table you identify. In this table here, recall from my my game. Let me show you this view again. So we have a host and a challenger, and a couple of action buttons, and then the game grid. So that maps to our struct here. There's the challenger and the host, or EOSIO names, and there's also a couple other names for intermediate states, and a vector of characters representing the current board. EOSIO name is an interesting type. The account names that we use with the EOS have particular requirements or restrictions on their contents. They have to be 12 characters, lowercase a through z, numbers 1 through 5, or a dot. And that's because of restrictions for this type called name. And the reason why it has those characteristics is it's actually a string rendering, an ASCII string rendering of a 32-bit number. So using the type name is very efficient for data storage and processing, because internally the name is treated as a number and only externally rendered as a string. Anyway, so that's the detail on the name and why the restrictions exist. Excuse me, the restrictions exist. Anyway, so because this is C++, we also have some internal operations that are used for initializing and resetting the game. And we come down here and we have more. So now let's get to the public section. And here we have a series of actions. Actions in a contract define the they define, well, the behavior for the contract. So actions can be executed by supplying a transaction with that name and whatever data set is necessary to pass. And notice all these have the identifier EOSIO action. You'll notice that the IDE, when you create a new project, use the macro for the action for the adornment. It's really up to you whether you use the macro or use the form that I show here. Anyway, so when you run the build command, you'll see something. Let's bring this up a little bit. Okay, I've seen this happen before. For some reason, the view down below is not rendering the intermediate output, but that's okay. What the point I was going to get to is to say that one of the things that compilation does is it generates an ABI file. The ABI file shown here is the interface definition for your contract. The interface definition is built up of 3 key elements: structs, actions, and tables. And the structs are used to define the parameter sets for the actions, as well as the data set for the tables. So what we have here is, you recall, so I had an action create, which takes a host and challenger, action restart, which also takes host and challenger, and a buy, an erase, and a move. And the move has a couple of well, cell identifiers. Anyway, so the structs in the ABI correspond to the parameter lists for each of those actions. So create, it defines a fields list with the name value pairs that all match the parameter sets. So this should be giving you an idea, if you are unfamiliar, of how actions are actually initiated, and how you can run them. So each of these actions have structs, and then also the data table, it also has a struct. And so you can see how you can identify the contents of the data table when you retrieve, if you use an action to retrieve that data. And I'll show you how that works in a little while. So next, after the structs, is the actions. And here we have each action has a name and a type. And the type is just the struct that contains the parameter set. There's also something called a Ricardian contract, which is part of the action definition. And the Ricardian contract is important because that's how you can define what the intent of the action is. So if there's a need for arbitration, it's the intent of the code as defined by the Ricardian contract that is the legal basis for settling whether the code is behaving correctly or not. There's been the comment with Ethereum, code is law, meaning that whatever the code does is what it is intended to do. But with EOS, intent is law, and so you have to write down what you intend the operation to do, and that's how you define. What is right. Okay, and so I'll show. So the source for Ricardian contracts are in a separate file, and basically written straightforward in Markdown language. And so that's the contracts. That's the Ricardian contracts. Before I move on, does anyone have any questions at this point? You see any questions? Okay. Well, we'll have opportunities for questions later on also. Okay, so yeah, I see. So the C++ syntax with the two square brackets, it's not a type in there. That's an attribute adornment, and this is a something that was introduced in C++ 11, and then later enhanced with C++ 17. And this is just sort of meta information about the operation or the function or the class. So in this case, EOSIO action is not actually modifying this void restart function, but it's supplying some meta information that can be used by a preprocessor or some other kind of code analysis tool. And in the case, like I said, of EOS, the ABI generator, which is used to create the ABI file, uses those to unambiguously identify which code are actions, which code are tables, this table, and what are contracts. So basically, it's used for disambiguation. Okay, so looking at some of the code. So the tic-tac-toe game has a lot of validation code. It also has state determination code, and of course the code for the actual contract behavior. So within the contract behavior code, this is where I wanted to show how so I may switch to another view. We'll stick with this for now. Okay, so when you push an action to a smart contract, smart contracts only exist in RAM during the run of your action. So all the state has to be retrieved before you can execute it. So in this case, we had that game table. This is where, of course, tables become very important, because tables, as defined here, is the only way to persist data for a smart contract. You can't have standalone variables in a contract class, because those will be destroyed and reinitialized. They'll be destroyed when your action ends, and then reinitialized when the contract is executed again. So you want to make sure your table, that all the data that you are interested in are stored in the table. Now, what we have is tables can be held in multi-index form, and it's shown using the multi-index table definition. Multi-index tables can be, as the name implies, can be indexed through a variety of means. And in this case, we're only doing a single key, which is the challenger name. And that's going to be a little more clear in a moment why we're using the challenger name and not something else like the host name or some arbitrary integer or something like that. Anyway, so we see a couple of things that are worth noting in this code that's on the screen right now. We see that in addition to defining a primary key and defining the multi-index table index, so when we look at the source code again, you'll see game index. You'll understand where that comes from. The other thing that this shows is the use of a serializer macro. This EOS lib serialize macro is necessary to allow the reflect APIs, which is part of the infrastructure, to actually serialize to store the in the table. So there's a few of these macros. We'll show you. I'll show you the others. So basically, when you need to you need to identify. We're having a little technical issue here. Cool. Okay. So the other macros that are necessary for smart contract deployment, you come over to the source file, scroll all the way down to the very bottom, and it's the EOSIO Dispatch. So yeah, a lot of work has been done to improve to minimize the redundancy, but there is still a little bit, which is not only do you have to identify which code or actions or tables or whatever, we have the EOSIO Dispatch, which takes the contract name and the list of all of the actions that are involved with the that can be pushed as part of transactions for your contract. So this one line here where it says EOSIO Dispatch, this one line actually encapsulates quite a lot of code, which if you're familiar with the very early smart contract forms, were quite verbose. So getting back to what I was saying about getting the code or getting the data to be available for an action. So let's take a look at this move action here. So this is the action that marks the XO on board game, and you can see what we do is we first create an instance of the game table, and so the because this is a table, we have an identifier which identifies the source of the table, which underscore code is the name that was provided by the contract base class to identify the code for this contract, and then host value. Host is a parameter supplied as an argument, and this is what is referred to as the contract scope or the data table. So with this, then we can further resolve within the scope table. We get then use the key previously defined, which is the value of the challenger name, to actually see if there's a game available. And so a few lines actually show some typical error checking, which you have. Okay. I apologize, folks. We have some serious connectivity issues happening here. My moderator is going to find out what the hell's going on. But anyway, so I seem to be up. Right. So let me get back. So I was talking about error handling. This is something else that you want to do when you're creating a smart contract for for professional deployment, because you want to be able to communicate whenever problems occur. So, okay. So assert is a macro. EOSIO assert is a macro that takes a truth statement. So takes a truth statement and a constant and a string. And the truth statement, if it's true, the code falls through and proceeds. And if it's false, then an exception is thrown back to the caller. Now, another important thing to be aware of, and when I highlight the client-side code, will be a little more clear, but the actions in EOSIO smart contracts are all asynchronous. In other words, you don't know exactly when the code is going to run, and so you can either wait explicitly for a response, or you can do some other behavior to access to determine the results. And so you want to use asserts to validate all the input and make sure that your contract is in a coherent state. And that's what we see here. Finally, there's a little bit of implementation code on how to actually do a tic-tac-toe turn. That's an implementation detail. So let me bring up some of the other neat things with the studio. And so I'll select the tic-tac-toe contract. And so there's a few things that you can see here that are really useful, and why this tool is such an advance. First, we have here a list of all the actions associated with the contract. So rather than having to deal with Cleos and the key store manager and everything, you can just execute your execute your actions right here. The data tables that are associated with the contract are available in this panel. So we have one table, which was called games, and of course, if we had more tables, they'd be listed. And here's that field for the scope. And the scope, recall, was an identifier that was used to name the constrain the data set to a particular account. So I'm going to put in one of my existing accounts. Oops. And we'll see what games exist for that. And so the data tables shown below are all of the rows associated with the named scope. So the scope in this case corresponds with the host column, and the challenger column was our primary key. Anyway, so this is how you can use the IDE to quickly identify the contents of your data table, which is useful for diagnostics, debugging, and so on. So let me look at some of the account details now. I mentioned this only briefly in the beginning, that you need some accounts. So let me show you how you actually can use these accounts to in order to well, run your program and test things out. So to create an account, do the drop down. There's a key. There's two menu items: create account and key pair manager. Key pair manager is not the CLIOS executable itself. It's an alternative that's provided by the EOS Studio itself. And so, again, heed the caution about mainnet key store usage, because it's possible for this key information to be leaked. This is for development purposes only. So you can, however, of course, import an existing key if you wish, or you can create a new one. So we'll create a new one, and you get, now this shows a view of the private key, which you could use if you're going to export this into or import this into another key store. So it might not be a bad idea to, if you're going to use another key store, say hardware wallet or something, you could capture this and store it. But I'm not going to bother with that right now because, because I don't have enough time. Anyway, so then the public key will become part of the list that's behind this. So I'm going to go ahead and save. And we added the new public key to our list. So we can copy that if we want. Close this window. And we can create a new account. And the account name has to be a valid EOSIO name, but because we're on a test network, it doesn't necessarily have to be exactly 12 characters. So let's do something, I don't know, I'll just use sample 3 since I'm not too creative. So we have a new account, and it picked one of the keys from our list. I'm going to use our new key, which we just created. And click on create, and presto, we have a new account. Now, didn't pull that up automatically. I'm not sure why. Anyway, so we select our new account. And as you can see, the infrastructure, or the studio, has already done a number of transactions for initializing this account. However, you end up with an account with the owner key and the active key having the same key associated with them. One sec. Okay, so I bring up the permissions because this is something that also is very important for dealing with smart contracts. You know, since smart contracts are the blockchain business of a decentralized app, you want to make sure that you have controls on who can do what with your contract. And so by default, there's two keys associated with every account. The owner key is used to guard changes to the account itself, and the active key is used to perform actions on behalf of this account. But there could be situations where you have more, where you want to have more restrictions on the account, and what kind of actions, or more restrictions on the smart contract, and what actions you want to provide access to. Now, I'm not going to get into actually configuring a multi-sig contract permission right now. It's a little too involved, but multi-sig is very important. Also, multi-sig stands for multiple signature, and what that means is that you can have permission sets that require, okay, someone is asking to create a new key. So before I get into, I'll just say it real quick. So creating a new key is trivial. Just use a key pair manager and click create. And this gives you a private key that you can copy and export into another key manager if you wish. However, because this is a test environment, I would consider any keys from this environment insecure and not to be used outside of this environment. I would not generate a mainnet key pair this way. Okay. So, popping back to discussing multi-sig and alternate permissions. So, with multi-sig, you can actually configure a permission that has multiple participants that can help you, for instance, recover an account, or have multiple parties to a transaction. Let's say you have a contract as real estate associated and you want to sell a house. You don't want to have someone just able to use the default action permission to sell your house. You want to make sure that when you have multiple parties involved, that all of those parties can participate in approval. So I can, however, show a quick example of setting an alternative permission, and I'll do that for on my tic-tac-toe game. I kind of glossed over this, but I have some code here that on the create, let me change this. So I'm using an old school technique of using pound if and else to selectively activate portions of code. And so now I'm doing is I'm turning on an alternative permission level for the create action for my contract. And this shows another macro, require auth, which has a couple of forms. The default form takes an account name and basically requires that your contract or that your transaction was signed with the active key for the named account. However, I'm going to use an alternative which takes both an account name and a permission name. I call this one Game Master just because, and uses that for the required authorization. So now we have to do a couple of steps to assign, to create that permission and assign it to a user or an account. So first, I'm going to build this again with permission, with the enhanced permission. And now you can see it's going through doing its business. And we've built, so to deploy. We're going to deploy to our tic-tac-toe game. And we've successfully deployed. So now, the contract. So now this create action, if I try to create it using the default action, you'll see that that doesn't work. So try to do a create using sample 3 and active. And you can see here, it says, oh, we didn't have our, I'm going to do one that I know works. Okay, change. I'm not going to speculate on why it didn't work. Okay, so now we see here that instead of starting the game, what happened was so we're missing the authority of game master. So we say, okay, well, let's add game master to that account. And the way we do that is we come over to the system account, which is called EOSIO, and select the update auth action. So this system account, as you can see, has a number of operations on it. And update auth is how we change keys or add keys. So this case, we're going to add a key called game master. So OCI TTT player 1. Permission we're going to add is game master. And the parent, this refers to permissions have hierarchy, and so we want to disconnect this from the active permission and set it to the game master permission. So we're going to set the parent of this to be the owner, which is the same permission, which is the parent of the active as well. And the last step here is this authority. The authority is the descriptor of the permission that we're going to apply. And so it's fairly complex. So what I'm going to do is actually copy one from another. This will be off screen for you, but it's taking me a second. Okay. So the authority or the auth parameter has a number of components. So accounts, this could be, if this were a multi-sig, accounts would be the list of participants in the multiple signature. Keys, of course, are the corresponding keys to those accounts. In this case, I'm only identifying a single key. And this is a public key because we're going to use our key store to validate that. And so this has a weight of 1. And the weight, again, is part of the multi-signature. If you have, when you define a multi-signature permission, you define a threshold, which shown here is also just 1, but the weights accumulate so that once the accumulated weights for multi-signature match or exceed the threshold, then the permission is granted. Weights for time are a second excuse me, are a second concept, which are that permissions can be delayed. So if you have a action, for instance, that transfers funds out of your account and deposit in another account, hang on, I apologize. You can set a wait time as opposed to a wait. Anyway, so you could set a wait time of, say, a day or 30 seconds or whatever you want. So that way, if someone got a hold of your key and tried to trigger a transaction you didn't authorize, you have a little bit of time to kill it. Anyway, so with all those values set, we're going to finish this now. Because we're actually modifying the player, the account, the permission that we need to authorize this action is the owner authorization. So finally, with all that, success. So we've now added to our account, and I'll bring up TTT player 1. And I suppose it's working its way through. Here's, actually, maybe I need to I had to refresh the view. Anyway, so here we have our new game master permission along with the active. And so these are both owned by the owner or descendant of the owner. And in this case, I did happen to use the same key pair as the active key, but in reality, you would, of course, want to use a separate key here as well. Okay, so now we've set our weight. So let's see what happens when we try to create a game now. So do create with a name. And our permission, we want to set to game master, because that's what we identified as our new permission. So we're going to do create, and we see it still didn't work. So the reason why this didn't work is we have one more step we have to do, and that is to link this permission with the action. So we have to come back here to our system contract and do link auth. And link auth allows us to bind the new permission that we defined. So in this case, player 1. The action is on the contract OCI tic-tac-toe, and the type is really the action name. And then scroll down. And the requirement is the permission name. Okay. And so authorization again is on the player 1. I think that's right. And let's see what happens. Okay, so this succeeded. So we've successfully linked our new game master for player 1 to the tic-tac-toe game. Let's come back here to create on the game. And unfortunately, I cleared out. I type it in one more time. And when I set the permission correctly, and this time we should have success. And success. So now you see the behavior of creating a custom permission and applying that to our action. And of course, we can verify set our scope to match to the host name. And there's sample 3 that we just created. Okay, let's see how we're doing. Does anyone have any questions here? And we'll show a little bit of the client-side code. So this is the client-side code, which is used to create the game using EOS.js as our as our tool set, and I'm not a JavaScript guy, so this is going to be a little clunky, but anyway, I wanted to show the important parts. So remember I said that all transactions are asynchronous, which means that when you execute a contract, when you execute an action, the response is not immediate. In fact, your application code, your client code could continue on at that point. And the only result you would get is either a successful run status or a failure run status. If it's a failure, then you get the exception that was shown in the IDE. So, a few things to point out. First of all, like I said, this is using the EOS.js tool set. And so we have this API, JSON RPC, and RPC error functions, which all require EOS.js. And also, because this is a simple test environment, we're using the embedded JS signature provider, which has some built-in keys and just makes it easy to stand up code very quickly. But looking for and again, I didn't create this code because I'm a back-end guy, not a front-end guy. But okay, here's something interesting. So when we do a move for the game, it first gathers up the parameters and sets the fields as identified in the ABI file. So if you're writing client code, you need to use the ABI file as your guide to the content of the calls. And here it shows we have to do a wait when we do the call, so that we can wait, because it's asynchronous. So we're doing an explicit wait here for response. Okay. The thing I'm looking for is a call called get table data. Let's see if I can find it. Get table rows. Okay, so get table rows. This is the API equivalent to the what was shown on the IDE for the table rows, in that you have table name, a scope name, and then some constraints on how much data to return. Because this is a simple exercise, we don't have a whole lot of data, but if you have a popular website or a popular DApp, you could have thousands or millions of rows in your data table. And so you can constrain how much data to get through the limit. So this is how you can determine whether your action is executed or not, by first running the action and then retrieving the table rows for the associated table, and with that you can then filter out the data set that you're looking for and act on it. Okay, so right. So yeah, I guess that's really all I have to say about client code. Well, let me bring back the API and see what else we can cover. Does anyone? Let's see. Okay, so yeah, get table rows gets this data table here. Okay, so I get a question: is there a way we can export keys from one machine and import on another? I'm not sure that you have to be careful with key management, because anytime that you reveal your private key, which is what you import, you bear a risk of revealing it to some nefarious player. So, like, you don't want to send it to yourself in an SMS text or in an email. You want to you probably want to use multiple keys and work well, I'm not really sure what the best way to deal with this is, but if you have a key pair that you create using command line tools or the key generator in EOS Studio, you have to consider those not to be very secure, so you can copy them any way you copy any other file. Otherwise, you probably want to use a hardware key and just carry that with you and have accessing software available on a platform that you're using that from. Does anyone else have questions? Now we're not quite to the end of the time, but I've pretty much covered all the topics I was going to I had planned. So does others have? What I was saying is I've reached the end of my code, my example. Yeah, I can put the example on GitHub. I think my GitHub account was revealed earlier. I think I can show it here. It's just pmesnier. And actually, the developers of EOS Studio plan to synchronize from the EOS Studio environment to GitHub, but they need to take a break for all the hard work they've been doing for the past few weeks and bring out EOS Studio Web.
Thank you everyone for joining us. We're going to go ahead and wrap up. Please be sure to visit objectcomputing.com/events. Stay up to date on all of our upcoming webinars. Thank you.